Hey everyone, welcome back to my channel. Today we're diving into something really exciting, a local PDF query app that allows you to ask questions about any PDF document and get instant accurate answers using AI. Imagine being able to quickly extract information from lengthy reports, research papers, or ebooks without manually searching through pages. Here's a quick demo of our PDF query app. As you can see, I've uploaded a PDF document, entered a question related to its content, and received a relevant answer. This tool is perfect for students, researchers, or anyone who works extensively with PDF documents. Now let's break down how we can create this app from scratch. Before we get started, let's go over the libraries that you need to build this app. Make sure that you have all this installed in your Python environment. So first we have Streamlit for building the interactive web interface. And secondly, LangChain, a powerful library for working with language models, handling document processing, text splitting, embeddings, and retrieval. And then we have FISE, that is Facebook AI Similarity Search, used for efficient similarity search and clustering of dense vectors. And then LLAMA, that provides access to the LLAMA3.2 model for generating embeddings and responses. And then we have temp_file for handling the temporary file storage. Run this command in your terminal to install all the necessary libraries. Once that's done, we're ready to start coding. Let's take a high-level overview of how our PDF query app works. Understanding the workflow will help us to dive into the code. So first we have PDF upload. The user uploads a PDF through the Streamlit interface, and then document loading. The uploaded PDF is loaded and converted into raw text, and then text splitting. The raw text is split into smaller manageable chunks to facilitate efficient processing, and then embeddings creation. Each text chunk is transformed into numerical embeddings using LLAMA3.2 model. Then we have vector store with FISE. These embeddings are stored in a FISE vector space, enabling fast and efficient similarity searches. And then we have question input. The user inputs a question related to the PDF content, and then retrieval and answer generation. The system retrieves the most relevant text chunks and uses the language model to generate a coherent answer. And finally, display answer. The generated answer is displayed back to the user in the Streamlit app. So here is the complete code of our RAG system. Now let's break down the code into different sections to understand how each part contributes to the overall functionality of the app. First, importing libraries. We need to import all the necessary libraries that our app will use. Here, Streamlit is used to create web interface for our app. By importing it as ST, we can easily call its functions to build the UI elements. Unstructured file loader. It's the part of LangChain, and this loader is specialized for handling unstructured documents like PDFs. It converts the uploaded PDFs into raw text that can be further processed. Recursive character text splitter. This tool splits large text into smaller chunks based on the character count, ensuring that each chunk is manageable for processing and embedding. And then we have LLAMA embeddings. This utilizes LLAMA's LLAMA3.2 model to convert text chunks into numerical embeddings, which are essential for similarity searches and AI responses. FISE, it's a library that efficiently indexes and searches through the large set of vectors, making it perfect for our use case. LLAMA is the interface to interact with the LLAMA's language model, here in our case LLAMA3.2, which we'll use to generate responses based on the retrieval text chunks. Retrieval QA combines retrieval and question answering functionalities, allowing the system to fetch the relevant information and generate answers seamlessly. Temp_file, a standard Python library used to handle temporary file storage, will use it to store the uploaded PDF temporarily before processing. Next, we set up the Streamlit app by defining the title and creating a file uploader widget. Here, st.title, this sets the title of our Streamlit app, making it clear to user what the app does. st.fileUploader creates a file uploader widget that allows user to upload the PDF files. With these lines, we have created a user-friendly interface where user can easily upload their PDF documents, loading and processing the PDF. Once the PDF is uploaded, we need to load its content and process it for analysis. Here's how we do that. Here, this condition ensures that the subsequent code runs only after the user has uploaded a PDF file. Temp file.name temporary file. This creates a temporary file that won't be deleted immediately after closing. This is necessary because some libraries require a file path to load the document. Temp file.write writes the content of the uploaded PDF to the temporary file. Temp file path stores the path of the temporary file for later use. Unstructured file loader initializes the loader with the path to the temporary PDF file. Loader.load extracts the raw text from the PDF and stores it in the documents variable. Recursive character text splitter initializes the text splitter to divide the documents into chunks of 1000 characters each, with an overlap of 200 characters between the consecutive chunks. This overlap helps to maintain context across the chunks. And text splitter.split documents splits the loaded document into smaller chunks and stores them in the text variable. By splitting the text into smaller chunks, we make it easier for our AI model to process and retrieve relevant information efficiently. Now that we have our text chunks, the next step is to create embeddings for them and store these embeddings in a vector store for efficient retrieval. Here, LLAMA embeddings initializes the embeddings generator using LLAMA's LLAMA3.2 model. This model converts text chunks into numerical vectors that captures semantic meaning of the text. Files.from documents creates a files vector store from the list of the text chunks using the generated embeddings. Files efficiently indexes these vectors, enabling rapid similarity searches. db.asRetriever. This converts the files vector into a retriever object. The search quark k is equal to 3 parameter specifies that the retriever should fetch the top 3 similarity text chunks for any given query. By creating embeddings and storing them in files, we enable our app to quickly find the most relevant sections of the PDF in response to the user queries. With our retriever in place, now we set up the language model and combine everything into a retriever QA chain, which will handle the question answering process. Here, LLAMA model equal to LLAMA3.2 initializes the LLAMA3.2 language model using LLAMA. This model will generate the natural language responses based on the retrieved text chunks. Retrieval QA.from chain type. This constructs a retrieval QA chain by combining the language model LLM with the retriever. Chain type is equal to stuff. This specifies the type of the chain to use. The stuff chain type typically concatenates all retrieved documents and feeds them into the language model to generate an answer. This setup allows our app to take a user question, retrieve the most relevant text chunks from the PDF, and generate a coherent answer using the language model. So finally, we add the functionality for the users to input their question and display the AI generated answer. So here, st.textInput adds a text input box where user can type their questions related to the uploaded PDF. And here, this if condition checks if the user has entered a question. QA-chain.run. This passes the user question through the retrieval QA chain, which retrieves the relevant text chunks and generates an answer using the language model. And st.write answer. This displays the generated answer below the input field, providing immediate feedback to the user. With these lines, the user can type in their question and the app will process and display the answer. We save this as app.py and then we navigate to the project directory and open the terminal or command prompt and then run the command Streamlit run app.py. After running the command, Streamlit will provide a local URL. You have to open this URL and then upload a PDF file using the uploader, and then ask a question, and then receive and view the answer generated by the AI. And there you have it, a fully functional local PDF query app built with Streamlit and LangChain. This tool can save you countless hours by allowing you to interact with your PDF documents in a smart and efficient way. If you found this video useful, please give it a thumbs up, subscribe to my channel and press the bell icon for more awesome tutorials. You can find the complete code on my GitHub. Link is provided in the description below. If you have any questions, feel free to leave a comment and I'll be happy to help. Thanks for watching. Have a nice time.